So what do you do when you have a carbon backbone that has multiple substituents on it? You just use the indices to indicate the location of all the substituents. And then if you have repeats of a substituent, so let's say multiple fluorines, you wouldn't write fluoro a bunch of times. Instead, you would just indicate with multiple indices separated by commas where the fluorines are. But you would actually have to add a prefix in front of that indicating how many there are. So if there's 2 fluorines, you would say difluoro. If there were 5, you would say pentafluoro. So let's look at this example. So here we've got 4 fluorines and 2 nitros. So how are we going to name this? Well, let's start by figuring out how to number the backbone. So we see that the longest chain is essentially the horizontal chain here. And to number it, we're going to go from left to right because we want to start in the place that puts the substituents at the lowest index. So that would mean that starting from the left would put 3 of those substituents on carbon 1. When we're adding them to the name, we want to make sure that we add these substituents in alphabetical order. So let's start with the name. So we're going to start with the fluorines because they come before nitro. So the location of the fluorines are 1, 1 because there's 2 of them, 3, 5, and then we would call this tetrafluoro. And then for the nitro, they're on 1 and 4, and it's dinitro, and then the backbone is hexane. So that's the name. Notice that the prefixes that we add to the substituent names don't change the alphabetization. So fluoro is still before nitro, even though tetra comes before di. So this is the order that you have to write the names in an IUPAC name. Let's try another example, and we're going to draw this one. We're going to draw 3-bromo, 4-chloro, 1,1-dimethyl cyclohexane. So start with the root. The root is cyclohexane, so draw a hexagon. 1,1-dimethyl. So you can start the numbering of a ring anywhere you want. So I'm just going to write these methyls at the top, indicating that that's position 1. And then I can put the bromo, which is the next one, either to the left or the right. It doesn't matter. I'm going to put it to the left. And then the chloro, because it's 4, has to be opposite the 2 methyls. So I'm going to put it at the bottom like that. So what do we do if we have an alkyl group that has substituents attached to that? Well, let's look at an example. So here, a cyclopentane is the root, and we have essentially a branched alkyl group coming off of it. So how do we name it? We name the alkyl group as if it were its own molecule. And so how would we name that group if it were its own molecule? We would first start by figuring out what the backbone is, so we have to number it. When we're numbering a substituent alkyl group, you always have to start at the carbon that's attached to the original backbone. So this is where it gets tricky. So this is not a propyl, even though it's 3 carbons. It's actually an ethyl because the numbering has to start at the original backbone. So the backbone of the substituent is actually 2. So it's an ethyl. And then the ethyl has a methyl coming off of it. So it's actually 1-methyl ethyl. And then the entire name is enclosed in parentheses. And then that is the full name of the substituent. So that substituent is in position 1. Again, you don't have to add this index, but I'm going to add it for clarity. So 1,1-methyl ethyl cyclopentane. So let's take a look at a couple of examples. We're going to name this compound. So what's the longest carbon chain? Is it the horizontal one? No, it actually goes down the downward branch all the way to the end of where the fluorine is. And where would we start the numbering? We'd actually start it at the bottom right to put the fluorine at the lowest possible index. So this is a nonane, and then the groups are fluorine and then this alkyl group. So what type of alkyl group is it? Again, we start at the carbon that's attached and find the longest chain. So in this case, it's only 2 carbons long, so it's an ethyl. So when we're naming it, it's actually going to be called dimethyl ethyl. But again, the di isn't part of the name, so we're going to call it methyl ethyl. And so when we're comparing fluoro and methyl ethyl, fluoro comes first. So we're going to start the name with 3-fluoro, and then the alkyl is on position 5, and it's going to be called 1,1 because there's 2 methyls coming off of the first carbon of the alkyl branch. And then the backbone of the substituent is an ethyl. And close that in parentheses, and the whole name is nonane. So let's try another example. Let's draw this molecule. So again, nonane is the backbone, so I'm going to start by drawing that. Now I'm going to draw 2 bromos, because it's dibromo, and I'm going to draw that on position 3, like that. And then in position 5, we have a propyl coming off. So I'm going to draw that first because that's the backbone of the substituent. And then there's a methyl on position 2 of the substituent. So that means if we count away from the carbon backbone, then it's on the second carbon away. So the methyl goes here, and that's the molecule.